Okay, hope you can see my screen with the presentation opened.
Yeah, we can see.
So a couple of words about the LeverX. The LeverX company was founded in 2003 year, and we have many offices worldwide. So the headquarters is situated in the Mountain View, California, in USA. Also, we have some offices in Riga, Latvia, Kiev, Ukraine. The Global Development Center and Delivery Center is located in Minsk, Belarus. Also, we recently opened the implementation center in the Uzbekistan, Tashkent. And also one of the headquarters is located in Germany. And at the current moment, the company has 800 plus employees, and our portfolio includes more than 500 project of implementation, and you can see it's more than 16 years of experience of real project implementations. And at the moment, we are the SAP Global Strategic Supplier, and tightly working with SAP and on the new, not only on the some project implementation, but also with the new functionality implementation, like new functionality development. So some of those new features that SAP provide to the customer every year. Some of those features are built by our developers and along with the SAP developers. So, and as I mentioned, we are tightly working on some common things. Okay, so, and for today, as I mentioned, the main topic is the production planning and detailed scheduling. So this is one of the modules of SAP, and just a couple of words, like overview, like a bit of history, how it starts and when it was founded. So this product, like PPDS, it was initially a part of standalone SAP solution, which was called APO, Advanced Planner and Optimizer. This solution includes some, not only PPDS, but also some another, I would say, modules like demand planning, like mid-term planning, like S&P solution, and like a short-term planning is used. It's the PPDS solution, production planning and detailed scheduling. And initially it was introduced maybe 20 years ago, like starting from 2000s year, and as of now, the PPDS solution is a part, because the strategy is a bit changed of development. Now PPDS is a part of S/4HANA releases, and now it starts more convenient for users, more convenient for the end customers to use the solution. It is not needed to install independent system like APO, start the integration, build all those integrational things, and customize the connections between different systems. Now the PPDS is a part of S/4HANA system, and it is the integration part was significantly simplified in terms of master data integration, in terms of transactional data integration, or like orders, like requirements, and so on. So, and at this point of time, so this is the very convenient for the customers to take a look at the PPDS without having APO solution as a standalone system, and it is very easy to take a look and understand what is what this solution can provide to the customer, what is the main benefits, what is the business profit for a specific customer could be taken from by using this PPDS solution. Okay, so it was a couple of words regarding the PPDS itself. And let's go further and talk about the concept, main concept of why it was invented. What is it at all? So as I mentioned, the PPDS solution was developed mainly for the short-term and maximum mid-term planning in the manufacturing plants, and in the time while, for example, demand plan solution take a look and take care about, for example, some annual plans, plans for a half a year. That in the PPDS solution from its side could manage the short-term horizon like a month, 2 months, maybe maximum 3 months, and with the very details on the production schedule build. Because for the annual planning, we don't need to have exact, for example, start time, end time for any specific orders. We just need to create some requirements, some demand, and just to try to cover this demand by creating some orders, some purchase orders, maybe. Start recording. Someone, could you please switch off your microphone? I hear the echo. No, yeah, okay, that was good. So as I mentioned, the main task for the demand planning is to understand how many work centers we need in the annual scope, how many, for example, raw materials we need to prepare and we need to buy, and for example, which is the budget of our plan. At the same time, the PPDS solution take a focus on as I mentioned, short-term horizon, for example, 1 month, 2 months, where we need to get the feasible production schedule with the exact order numbers, with exact quantities, with exact timing of the order execution, like when the order should be started, when the order is ended, and so on. And this production plan should be feasible in terms of the orders should not overlap on the same resource, because of course in this case it would not be feasible to execute this plan, and so on. So this is the main, I would say, goal of the PPDS and this solution, to build the feasible production schedule in the short-term horizon. Basically the PPDS use the same planning concept as the classical MRP, but it's just the beginning, because if you know the MRP, and currently it's called like MRP Live in S/4HANA system, the material requirements planning just covers one task. It creates some procurement proposals, like in-house production orders, like purchase orders, just to cover the existing demand, like the sales orders, like the forecast. But the MRP doesn't manage whether this plan is feasible from the resource load perspective. What I mean, that, for example, it creates some in-house production orders, but in the same time, these orders might be overlapped, might be put in the same time, and the resources will be overloaded. So it's not feasible to execute this production plan following this production schedule built by MRP. So this is the main, I would say, lack of data provided by MRP. So the PPDS successfully covers this gap from which not covered by MRP, and can provide you after some optimization steps, after some rescheduling steps, can provide you some feasible production plan. One of the advantages of PPDS, you don't need to create the separate master data in the system for the PPDS to make it work, because it uses the same master data as use S/4HANA, as use the classical MRP, like the plants, vendors, like the customers, materials, bills of materials, recipes, routines, and so on. So all this data just simply integrated with PPDS solution. Now it is in S/4HANA, so we even don't need to run any background jobs. It automatically goes to PPDS, and we can use it without any restrictions. What else? So as I mentioned, it's not only the in-house production, it also might be used for optimizing the supply chain for the purchasing, like the ATP check, so availability check of materials from different plants and so on. Also, we can manage the storage resources, like some warehouse resources and their capacities, to understand whether we can keep some stock on hand, or we have some restrictions in the stock keeping. And okay, let's go to the next slide. So here just we'll say a couple of words regarding the main advantages of PPDS. So the first one is the one planning run for material requirements planning and the order finite scheduling. So what does it mean, finite scheduling? The finite means the scheduling happens using the exact time. For example, not only hours, not only days, but even the seconds. So the system even can manage the seconds to schedule the order, to schedule the order start, to schedule the order date, and so on. This allows to build the comprehensive scheduling not only from the for example, in-house order perspective, but using so-called relationships between orders, between demand and proposals. And of course, in the real in the real world, nobody works using the seconds, but at least in the first approach, it allows to understand whether this plan is at all feasible or not. And then we just use some buffer times, some tear down times, some setup times to adjust our schedule to make it more feasible for the real shop floor execution and so on. Because the shop floor execution, it's almost always, it's kind of force majeure situation happens, and we need to take some responsibility on how we can manage any critical situations and how we can easily replan, and PPDS allows to do this. Regarding the one planning run, what I started talking, so it means the PPDS could run MRP, could run optimization, could run finite scheduling, could run some service heuristics like orders, backlog removal, and so on in one planning scenario. You don't need to run, for example, several transactions to get the feasible results, to get the feasible production plan. You just run the one job execution, and you can get the correct results at the finish. What else? So one of the advantages, this is automatic source of supply determination. So based on the procurement lead time, system could choose the most efficient source of supply, like whether it is external procurement, whether this is kind of different suppliers, and system could choose the most efficient supplier. Or for example, if we're talking about the in-house production, it's mainly connected to the alternative resources. It's a very major topic, how the system can manage, for example, if we have 3 work centers or 10 work centers, how the system could manage it in automatic mode and choose the correct one. Choose not, for example, not overloaded work center in the proper manner. So the rest of things like characteristics-based planning, optimizer, and alert monitor to handle the critical situations. It's it's a part of the PPDS solution, and of course there are very lot of possibilities it includes. But for today's session, I will propose to concentrate only on a couple of them. And so this part, next 10 minutes will be more theoretical, I could say, but then for half an hour, we will try to see some demo in the system, and we'll try to present you some specific cases, how the system could manage these cases and build the production schedule in some correct manner. So this is about the integration, as I mentioned. As of now, the S/4HANA and PPDS. So the PPDS solution is a part of S/4HANA, so it uses the simple data replication for almost all the data. So we don't need even build some integration jobs, some integration system setup, and so on. It significantly simplifies the system implementation and reduce the time on the project implementation, and also avoid to take some maybe some errors in integration, because it's also very crucial. A couple of words about the master data. As I mentioned, the systems use the same master data as S/4HANA. So this is the products, this is the locations. Like location might be the customer, the production plant, the supplier, and so on and so on. It's just every I would say key point in the supply chain. Also, system uses, of course, resources. So in S/4HANA, it's kind of called work center. In PPDS, it's just a resource because the work center is more, I would say, comprehensive definition, but the resource, because one work center, for example, in S/4HANA could take a couple of resources, like machine resource or like labor resource, and so this kind of data also tightly integrated between systems. Regarding the master data for manufacturing, like the bill of materials, like the routines, like the production versions, if you already use this SAP solution, or even if you don't use the SAP, but you are a company that uses some that mainly you work with in manufacturing processes, you already know that this is the mandatory part of the data is the bill of material, recipe, or routine. And of course, all these types, all the data types are used in PPDS, because this is, I would say, the baseline for the PPDS to make some calculations. And in PPDS system, all this data like BOM, routine, and production version are combined to one structure, which is called production data structure. So just because in PPDS, it's more technical object, because mainly you do the maintenance of the data. You create the bill of material, you create the routine, you create the production version in S/4HANA, and then just replicate them to PPDS. And even on PPDS side, you don't need to pay attention to this, because it's mainly automatically uploaded to PPDS, and you just kind of take a look on the technical point of view, from technical point of view, but at least you don't need to pay attention how it is represented in the PPDS, because mainly the data is maintained in S/4HANA. And regarding the planning concept in PPDS, so the main, as I mentioned, the PPDS provides not only like MRP kind planning, but also provides some scheduling strategies, provides some optimizer, the possibilities, optimization possibilities. So every program which is defined to solve some specific planning task is called a heuristic. So that's why in PPDS it's called like heuristic-based planning, and each heuristic represents a specific logic that solves specific planning task. And SAP, of course, in the standard solution, SAP provides some maybe 20 or maybe 40 standard heuristics for the most common cases in the planning, and which covers the most of the situations. Of course, in case there are some gaps in heuristics, we can build our own heuristics and customize it in a way that we can, for example, could manage some planning situations with our specific planning data, with our specific planning requirements. And as I mentioned, this is the scenarios planning. That means we can build a scenario for the planning and use different heuristics with the optimization in the same time, and running one job. Running one MRP, and the scheduling optimization in one scenario, we can get the feasible production plant. plan. So basically, the main steps which is needed from the production planner in this case, as I mentioned, this is the planning scenario adjustment. So the planner just usually it's not the real case, but of course, planner could influence on the system behavior on what system should run, but usually it's customized in the way as the background jobs with specific scenarios, and system will take majority in this process, and just the main task of the planner to evaluate the results and to do some minor corrections in the schedule built by the system. This is I would say main task for the planner, to control the system, control the results. Okay. This is the heuristics which we talked about. So the resource, yeah, and regarding the results evaluation, because we started to talk about how to evaluate results, the PPDS solution provides different views, different reports. Each report provides some data from specific point of view, like a resource planning table. We can check on the resources, which resources loaded, not loaded, overloaded, where we have the critical situations on the resources, which is the what is the order sequence which is scheduled on the resources. The second one is the product planning table. So the product planning table shows us the situations which happens on the products, and using the seeing the products in the list, seeing some critical alerts, we can take some activities and do some changes to avoid these alerts. Also, we can use some order networks because system could at any time, so system calculates so-called peg-in relationship. This is the connection between, for example, in-house order and the sales order, or forecast requirement, and the purchase order. And this connection allows system to understand whether it is feasible to achieve this, for example, product stock on time or not possible. One of the features of the PPDS, it's the visualization of the production schedule, because sometimes it's maybe more easier to understand what is happening in the system by looking at the so-called Gantt chart, and in this graphic form you can easily understand what is happening in the system. And you can even, this is the interactive chart, you can do some actions in this interactive chart as well, and save the planning results. Of course, in the real life, where we have possible hundreds of orders, it's not, I would say, the regular manner to use this graphical tool, but at least we can use it for some specific work centers, some bottlenecks, and the rest of work centers, the rest of resources like cutting machine and so on, with the huge of orders, could be managed in some tabular form, which is more easier to understand, which we can where we can see the sequence of orders in the easy manner, from which we can print out the task for manufacturing, the task for the shop floor, for workers, for the work centers, and so on. As I mentioned, one of the nice features is the optimizer, because optimizer is kind of a universal tool which allows to build the production schedule using some criteria, and using like the setup time, like the make span of the production plan, like mode cost is kind of what the resource is used, and whether it's the resource is the optimal or not optimal. And so optimizer could build some solution and take a decision on what would be the best way in the building of a specific production schedule for specific resources in the specific time horizon. Okay, this was the theoretical part, and I think we can continue with this our demo. I hope now it will be more interesting to you, and because we will try to showcase some main features. of the PPDS. So regarding the master data, so as I mentioned, just a couple of words about the materials, how it is looking. As I mentioned, the material master, it's in S/4HANA could be used without any restrictions. In PPDS, it's the main data maintained under Advanced Planning tab. Just the couple of parameters to be maintained, and that's it. So the rest of things, the system done automatically using, as I mentioned, some heuristics or optimizer. What else? As I mentioned, the critical part is the routines, because the routine represents the operation sequence, represents the resources which are used in the production process, and this is more critical data for the optimization, because, for example, here you can see to produce some kitchen chair, we need to execute 3 operations like cutting, drilling, painting. Each operation could take some setup time, could take some machine time, and the labor time as well. And all this kind of time is taken into account by PPDS while building the schedule. Also, we can use some classification activities, like you see there is, for example, we can classify some operations with some specific values, like now you can see the cutting machine. What does it mean? We can classify our alternative work centers, like we have, because, for example, if we have 10 cutting machines and we would like to put the system in the way that the system could choose the best one, we can just do the classification, and system will try to use all alternative work centers, all alternative cutting machines in the way that the production schedule will be feasible, and we can provide the stock to the customers on time. Okay, so, and one more thing which I would like to show, this is the resources. This is also the main part of the system. So basically, this is if you work in SAP, the resource, it's, as I mentioned, this is the part of work center, because the resource could take, I would say, for any specific capacity, like machine capacity, labor capacity, it is every capacity represented by resource. So, for example, you can see we have drilling machine resource. We have some parameters for this resource, some calendar, some start working time, end time, some break duration. Also, we have we can put some downtimes for the resources. It might be put for any downtimes, planning downtimes or actual downtimes. Okay, and one more thing is the setup matrix. The setup matrix is used to represent the data, to represent the time which is need to be put to the shop floor, for example, before running the operation, and because in the real production, because, for example, if we try to do the operation on the different products, it might take some time, because we need to change our production resource tools. We need to set up our machine in the proper manner. So, and here, using the so-called setup keys, we can assign the setup keys to our routine operations, and system will try to build the optimum production schedule to have to minimize the setup time in the feasible manner. And in this case, we will try to manage in the system. Okay, let's start our demo. At first, we have to put the demand in the system, and it might be the sales order, or it might be the forecast as the plant independent requirements. So just pay attention, please. We have 3 materials to be produced. On the 17th of December, we forecasted some quantities. As I mentioned, it could be also raised by any sales orders as well, but that doesn't matter. But we expect these quantities to be produced on 17th. So the planner, now the planner needs to understand whether it is possible at all, not possible, or if it is possible, we need to understand whether some critical situations may happen. Okay. Now I go to just to show the initial situation. I will go to product planning table, and as I mentioned, this is a special report which shows us some critical situations from the product point of view. So here we have our products in the location, and just please pay attention to the error indicator. This is the so-called alerts. It shows us that we have some critical problems. And okay, let's open the alert monitor. So here system shows us what is the problem with our products. So system shows this is the forecast, and this forecast, the requirements from the forecast not covered. It's kind of requirement on the coverage and the stock shortage we have. So the system shows the products and so on. So all the kind of information not related only to the products, but only for the resources as well, for the resource overloads, also shown by the alert monitor in every report. And if we take a look to the lower table, we can see the details on the selected product. We can see our forecasted requirements, which should be fulfilled on the 17th of December, and the quantity 120 pieces, and the quantity alert raised here. In the upper table, we can see the resource view. It's kind of a lot of the resources for any periods. It might be day, month, week. We can just easily adjust these periods. And as of now, we can see there is no any resource loads exist because not yet the orders not yet created for in-house production. So what I doing as of now, I will run MRP and we will see what is happening. What will happen in the system, and we will try to simulate how the S/4HANA works without the PPDS in this manner. So before that, I will open the scheduling planning board to have the nice overview of the in the graphical form. So as of now, we can see there is no any orders, no any operations planned, and let's run our MRP. I'm just choose the specific scenarios for planning and with the MRP without any scheduling, and now it's we will get the situation how it is how it looks like just after the material requirements planning without any scheduling, because the MRP could not, for example, do the scheduling in automatic mode in time of the MRP run. And just refresh the system. Okay, and hope you see the system generates the operations, generate the orders, and tries to build the schedule based on the length of the orders and so on. Now we can see it's kind of possible to produce the products on time, but this is one key point that should be taken into account. If you see the resource utilization chart in the lower table, we can see some peaks, some overloads, some red lines that shows us the resources are overloaded. This is what happened just after the MRP run. So if you use the S/4HANA, you always get this situation. Yeah, the orders are created, but the resource overload are not taken into account and could not be managed. The same we can see in the, for example, from the product point of view, what we can see as of now. For the product itself, there are no any alerts exist because the products could be provided on time as we saw. But for the resource point of view, we can see some overloads happens. Some days are not overloaded, some days are overloaded. So that means we need to execute scheduling and try to manage these overloads. Also, let me show you one more view. It's so-called resource planning table, where we can take a look from the resource point of view, what is happening in details. Okay. So we can see that some of our resources are overloaded, and by double click on the specific resource, we can directly go to the problem periods where we can evaluate. For example, on 14th, there is no any overload. On 15th, we can see some overload happens. We can see the orders which overloads these resources, and we can see also that some orders are overlapped, which we also saw in the graphical form. We need here we understand that we need to do some activities to solve these situations. And as I mentioned, this is the alert monitor, where we can see all the details. For example, we can see the cross order overloads. That means some resources are used by different orders in the same time, the same resource, and the overloads even between different operations. So the main task for the planner as of now to do the scheduling and to avoid these overloads. Okay, and let's execute such case. I will do the scheduling in graphical form, because, as I mentioned, usually this kind of jobs, it's not done in the interactive mode. It's interactive, it's just only for some critical situations, but usually it is done by a system in automatic background jobs, and just planner will just do slight changes, then slight adjustments of the schedule. But as of now, to have it more easier to understand what is happening, I do some replanning steps in manual manner. So I select the orders to be rescheduled and called one of the heuristic, which is the main task to do the scheduling and avoid overloads of the resources. I am using the backward scheduling. Okay, so now what we can see, the system reschedule all the operations in the manner that now there is no overloads could happen. I will save the planning results, and we still see that, yeah, it's still possible to execute. At the first look, it's kind of still possible to provide all the stock on time, but what we see, one of the operation is put to past, which is not, of course, which is not possible in the real production. And if we go to alert monitor system, so even in this case, we have to do some additional steps in the rescheduling, because kind of remove backlog, because it's, of course, in the real production it's not possible to start in the past, and we need do some adjustments. And now I'm doing it's kind of in interactive mode, but as I mentioned, just one more time, all these kind of activities are usually done by background jobs in the system, which predefined with specific heuristics, specific optimization steps. So to solve this situation, what I can do, I can use the remove backlog heuristic, and system just keeping the sequence. System reschedule our production, just shifting from starting from the current time. And but what we can see as of now, the system restricts our let's say requirement date, requirement time, and it's not let's say possible to produce following by this schedule to produce our materials on time. Let's save the results and see from the resource point of view what is happening. I will switch back to the resource overview. And now it was previously, you can see it was some errors, it's some overloads. Pay attention, it was some overloads on specific dates. And now if I update this resource table, it shows no overloads exist. The resource are utilized in the correct manner. There is no overloads happen, so I can click another resource and see some orders, which is planned on some specific dates. For example, here I can see what is happening. There are 2 orders scheduled and no any overloads exist. And let's take a look from the product point of view. Extend products, and but from the product point of view, what we can see, the 2 products could be supplied on time, but the one of them we can see just warning, because system warns us that what is happening. Let's see. Alert. What is our alert monitor? Yeah, we have some warning from the product. So the product is too late. So it means the system determines that it's not possible to achieve this product on time, and system also calculates some delay time and so on. So this kind of information already also available from any reports which is provided by PPDS. So planner could easily drill down and check details. What is the problem, and where we need to put our attention. Okay, so how we can proceed further to optimize the schedule in more feasible manner. We have following 2 cases. The first one is the resource alternative resource planning. For example, because we can see that the system has this operation has 2 possible alternatives, like a cutting machine 100, 200, and 300. There are 3 possible alternatives, and system could use these alternatives to try to minimize the schedule. The second case is here you can see just a couple of bit of explanation. This is the presentation of operation, and this part, like a red part and the blue part. The blue part represents the processing activities. The red part representing the setup activities. This green part in the drilling operation, for example, also represents the setup activities. But what is the difference? The green means this is the fixed setup time, so we can't do some kind of optimization using the setup time, because it is already fixed for this operation. But when it is shown out there under red graphics, it shows that it is possible to do some optimizations in terms of setup time minimization. You can see the orders now are put in the way that we have high setup time for the first and for the second order, and only for the third order the setup time would be reduced. And what we can do as of now, we can run the optimizer, and we'll try to use setup time optimization to have the more feasible results in the planning. So I just select the resources to be optimized, call the optimizer, and just a couple of words about the optimizer, because it's a very interesting feature, and it allows us to put some critical and the weight of criteria, and system based on these weights try to build a schedule and to try to take into account all the possible restrictions, like the alternative resources, like setup time optimization, like the requirement dates, lateness, earliness, and so on and so on. There are a lot of parameters are taken into account, and you also see there are some setup time costs. Times could also be taken. And what I'm running as of now, so I'm use the same resources for the planning, which is used as of now. Just will show what is the difference with the scheduling. Just let me just go back and pay attention to the end time of the last operation. It's ended almost until at 16th, 17th of December and 16. Okay, and let's run optimizer. So it's built some solution. It shows with the graphic what is the solution, how the calculation happens. Okay, and now let's see what was done. So you can see it was because previously we can see there are some operations was scheduled in some manner that it was setup time, huge setup time for the second order as well. Now the system will reschedule the orders in the manner that, for example, it is taking care that now the system changed the order sequence in the way that reduced the schedule. Just let me do some more adjustment because that some time passed. I need to just change the horizon. It should be the 10th, of course. Let me run it one more time. Okay, so now it should be more clear. So also I remove the backlog to start with the current time. And now what we can see, it was almost ended the last operation at the 16th. Now it is reduced almost for 1.5 hours by the means of reducing the setup time and by changing the sequence of orders in the correct manner. So I save the results. So this is the one of the advantages. So even after the scheduling, you can see it is not, I would say, possible to reduce anymore. You can run the optimization and the system will try to reduce it by some different techniques like setup time optimization. And what could be done next? Because now we also see that we still not, it is still not possible to achieve the optimization schedule in the correct manner, to optimize the schedule in the manner that we are ready to, with the last product, ready to provide the last product on time. We can use so-called resource optimization. I just can open it, for example, open the operation, and as I mentioned previously, if it is possible to reuse some alternative resources, system will try to do this. And let's try to, because now, for example, this cutting operation is scheduled on the cutting machine. And of course, this cutting machine is kind of bottleneck for us because it takes some time for the orders, because we need to wait for the last cutting operation is done on the then we can continue with drilling and continue with, for example, painting. So we are restricted here. And now we can try to eliminate this bottleneck. So I run the optimization and just do slight changes in the settings. So now I'm allowing to system to use any mode. I mean any resource. So now we can see from the solution, it reduces make span. So make span, it's kind of length of the production schedule. And let's see what is happening. Okay. Also, let me remove the backlog. Backlog. Okay. So let's see what is happening as of now. So you remember it was all three operations for cutting. It was scheduled on the first cutting machine, and as of now, the system automatically rescheduled the cutting, one of the cutting operation on the another machine. And also system more, I would say, more take care about whether it is, I would say, whether it is reasonable to use all three machines or it is just enough to use only two machines. Because in our, for example, situation system, understand that even if we use the trim cutting machines, it is not possible to reduce the time, to reduce this mic span of the schedule more, because we have some painting work center, like our bottleneck, and we are restricted with this painting work center. So also what we can see as of now, the system put the schedule and also reduce the schedule in the manner that now we just only 1 hour late of our I would say 1 hour lateness from the requirement delivery date and time. So system almost done the almost done the rescheduling in the correct manner. And of course, in the real situations, there might be this, critical points when the system could not manage some points, and the planner could take the responsibility. What could be changed? For example, in this case, planner could understand, okay, we could not provide the same quantity on time, but it is very crucial, but we can change the demand. We can reduce demand for a couple of pieces of product and the reschedule, and in this case, it allows us to produce on time. Also, of course, it's not in the real situation. Usually, shop floor doesn't work in the manner as we see here, because there are orders, there are gaps between orders, and it's kind of, yeah, it's good for the rescheduling, and I would say to understand whether it is possible to follow this schedule. But in the shop floor, I would say it's not the manner how the shop floor works. In this case, I just show one more scenario. It would be the last scenario with the optimization, where I will use some kind of step-by-step optimization scenario, and system will try to build feasible schedule without any gaps between operations, because this is how it usually shop floor works. And I'll go to the planning scenario. I'm using specific, this is our customized strategy. So we have several steps of optimization. Each step takes some specific resources in specific order, and just let execute it and we'll see. Okay, it's done. And let's get back to our production schedule, refresh it. Okay, and what we see as of now, the system eliminates the gaps between the operations. So that means we can follow this schedule. Now in the real production, there are no gaps between, for example, on the cutting machine, there are no gaps on drilling machine, and there are no gaps on painting machine. And we can see the same in, for example, resource planning table where we can see about the resources. We still see no any warnings, and the production schedule is feasible. And just let me change the periods, like choose the month. So we can evaluate the resource utilization on, for example, for the month. We can see this cutting machine is loaded on only 12%. For example, this drilling machine is loaded on the 10%, and we can also see the orders in the lower table. We can see the orders, and the orders are put without any gaps, so they are go one by one. So this is usually how it happens in the shop floor. What is the data? What is the data that is provided to the shop floor after any optimization runs, and so on. So usually using this report, you can print out the tasks for the shop floor for specific resources, and distribute this task to the shop floor, to the workers, and try to follow this task. Of course, in the real situations, there might be some changes, some breaks of machines, and so on and so on, some force majeures. Of course, in this case, to have the correct, correct visibility of the situation, we just usually schedule so-called background service job, which is which remove backlog, which shows the current, I would say, the current status of the orders, whether it is under execution, whether it is a receipt, not receipt, and so on and so on. So in this manner, we can just adjust the schedule and try to follow, try to see the real picture of what is happened in the exact time in the shop floor. Also, one more thing, I think it will be the last for today. We can also do the so-called simulation, because it's very important for the planner to understand whether we can change something and how we can compare these changes to each other. For example, once I build some schedule, I can, for example, shift some operation to another time slot. For example, if I try to shift it to this way, it automatically shifts me the painting because it's a dependent operation. Or I can shift this in another manner, like shift painting. And I can save it in the simulation version. For example, when I save it, I can say, okay, I save it to the simulation version 02 and save. And refresh it once again. Okay. And then, for example, if I close it, open once again. So just to make sure, in the production version, in the productive version, we don't see these changes which was saved to simulation. We just see the real situation, how the production will happen. But in the same time, if we go back and try to open our simulation versions, for example, we can see our version 002, open the graphical form of it. And here we can see the drilling and painting operation scheduled in another way, in another manner, which I did previously with the gaps between the rest of operations. Okay. So I think for today, I tried to showcase some, maybe one of the interesting techniques of the system. It was, of course, it was not enough time for the half an hour, just for the first look, because features of the PPDS is a lot of features. It has, but I hope it was at least something was more understandable for you, and now you can raise your questions if such exist.